Hi, this is a quick review of our lesson 2.05 Applications of Linear Equations. Let me grab my pen here. So here's one of the questions we're going to go over. It says that there's a total of $3.90 worth of money, and this includes both nickels and quarters. So the first thing I think of when I see that nickels, we want to turn that word into a value. So we're going to change that to 0.05, right? Because a nickel is 5 cents. And quarters would be 0.25 because a quarter is 25 cents. Then it tells us there are 6 more quarters than nickels. 6 more quarters than nickels. So how many quarters do we have? Let's see, quarters would be, well, we know there are 6 more than nickels. So we can write that as 6 plus n if we let n equal nickels. So that's just a way that we could write the quarters in reference to n, to nickels, because there are 6 more of them. Now the question says, how many of each are in the piggy bank? Well, we know that we're going to add up the nickels and the quarters together to give us the total. So what's the total? The total equals $3.90. So we have to include the nickels and the quarters. So nickels is n. But since we're dealing with the amount of money, $3.90, we need to figure out the number of nickels, but also how much money are nickels, right? How much of this $3.90 is nickels? So all we have to do is multiply 0.05 times n. That would give us the amount of money in nickels, right? So if we had 1 nickel, that'd be 0.05 times 1. That'd be 5 cents. If we had 2 nickels, we'd plug in 2 for n. 0.05 times 2, that would be 10 cents. So it's just a way for us to multiply the value of the coin times the number of the coins. And we're going to add it to the quarters. So a quarter is 0.25. But remember, we let quarters equal this expression because it told us there were 6 more than. So we're going to multiply 25 cents by that whole thing, 6 plus n. All right, well, now that we have the equation, I think that's the hardest part. All we have to do now is solve for n. So since we have a set of parentheses here, let's distribute the 0.25 to everything on the inside. And my pen must need to be recalibrated again. It's acting up. So we're going to have 0.25 times 6 plus 0.25 times n equals 390. So 0.25 times 6 is actually 0.3. It's not 0.3. Let me see if I can erase that. Eraser. Hey, that worked. All right, 0.25 times 6 is 1.5. All right, now we can combine like terms. Look, here's an n and here's an n. So all we have to do is add those coefficients, 0.05 plus 0.25. That's the 0.3. 0.3n equals 390. Now we're going to keep solving. We're going to keep trying to get n all by itself. So let's do the inverse operation to get rid of this 1.5. This is a positive 1.5, so I'm just going to subtract it from both sides. It's going to get rid of it for us over here because 1.5 minus 1.5 is 0. Bring down the 0.3n. And you can absolutely use your calculator for this problem. 3.9 minus 1.5 is 2.4. Now our last step is to get this n by itself still. So this is 0.3 times n. So we need to do the inverse of multiplication, and that's division. So we're going to divide both sides by 0.3. And you get n equals 8. So funny how all those decimals came down to an 8. So there are 8 nickels. Now it did say how many of each coin. So once you find the number of nickels, this is n, right? All you have to do is essentially plug that back in up here where n is. So the quarters would be 6 plus 8, which is 14. So there are 14 quarters, woo, and 8 nickels. All right, let's try the next one. I find these problems to be like almost so, it's so easy it's hard. Do you ever think that way? Like there's so many words, but you know it's got to be easier than what they're making it out to be, and more than likely it is. So let's highlight some stuff. We have the trains traveling at the same speed. That's good news. They're going in opposite direction. Train A reaches the station after, now this copied funny from our OMHS. That's actually supposed to be 2.5 hours. 2.5 hours. And then train B reaches the station after 4 hours. They are a total of 585 miles apart. So I'm super visual. The first thing I wanted to do was draw a picture. So I don't claim to be an artist at all. And of course, like I told you, my pen is not happy with me today. It was working great last week. I don't know what is up. So it did tell us that the trains leave Central Station going in opposite directions. So I'm just making a straight line. All right, so train B leaves the station and ends up at station B. And that takes how long? 4 hours. So I'm going to label this length of 4 hours. And then train A leaves Central Station and goes to station A, and that takes 2.5 hours. Now they're a total of 585 miles apart. So on the top we've labeled the time. So down here, the entire distance I'm going to label 585 miles. So in your OMHS, it talks about a few different formulas that we're going to be using, and most of them you've been using for a few years now, things like perimeter and area and distance. So we know distance to be rate times time. Distance equals rate times time. So all we need to do is plug in what we know. We know the distance. The total distance is 585. So I'm going to plug that in for D. And that's miles. You don't really have to put in the miles if you don't want to. It's a label here. It's not variable. So just make sure you know that. It's a label. All right, we don't know the rate. That's what it's asking for, right? What is the rate? But we do know the time, the total time it took. Now we can add it up, right? 4 plus 2.5 is 6.5 hours. And I took the total time because I took the total distance. You could essentially split it up, but we don't know how much of this 585 station or train B used and how much train A used. All right, so then we could figure it out once we get the rate though. All right, so now all we have to do is solve for R. This only works because they told us it was traveling at the same speed. So that's why we're able to solve for a single R. So to get R by itself, this is multiplication, so the inverse is division. So we're going to divide both sides by 6.5. And R, again, you can use your calculator. Oh, remember the 6.5 was hours? Again, you don't have to put the labels in, but in this problem, it's kind of helpful. So we end up with 90, check it out, miles per hour. I'm just going to write MPH. You didn't really have to use the labels throughout. You guys probably know that speed is measured in miles per hour with a train, so you could just wait till the end to add that label. But the rate, again, because they were going the same speed, is 90 miles per hour.